Hey everyone, we all know that 12-volt power is really scary, but what some people don't realise is that once everything's plugged in your system, whilst you should in general leave it alone and not constantly, take the cable out and plug it back in, there are some things you can actually do to actually test whether your 12-volt power cable is installed correctly and running safely or not. So that's what I wanted to talk about in this video, along with touching on things like the actual specification and the design for the 12-volt power connector, and how things like digital calipers could potentially help you. And one of the things that actually prompted me to make this video is that I always advise people on my previous videos to use like a native cable that comes with your power supply unit, or maybe use the squid adapter, even though I'm not as much of a fan of them. But recently I actually picked up a cable mod right angle 12-volt power cable, which might seem like a weird idea considering cable mod actually had issues with them and needed to recall loads of them. And in theory now the design is safe and hopefully this setup is completely fine, but yeah, it was still a bit of a concern for me, so I wanted to actually test out this cable mod cable in this video with like a DC clamp meter and a thermal camera and everything else, and as a result show you how you can actually test your 12-volt power cable too. And whilst I will get into like more scientific testing in a minute, one of the first things you should do is check that your 12-volt power cable is actually plugged in properly and it's installed in a way where it's not bent. And for example, when I had my cable mod 12-volt power cable, there was a QR code on there that took me to this particular page, and it's actually really useful, so I'll link to it down in the description. But one of the first things it says is when you're actually installing like your 12-volt power cable, you should check this actually not like bent vertically or horizontally. So basically, if you've got your actual cable there and then you bend it right at the actual tip of the actual connector, what can happen is that can place too much stress on the actual cable, and potentially some of them could pop out or have slightly worse contact, and that could then lead to a current imbalance when you're actually powering your graphics card. And you might be thinking, well, this particular graphics card clearly is bent vertically, but this is actually a right-angled cable that's designed for that. So Cable Mod have engineered this fairly high quality cable, I hope, in a way that actually, reduces the chance of melting or whatever, even though it is bent and it's not in line with this. But that's what this first thing says, is that because the connector is so tiny, if you actually yank this, horizontally or vertically in a way that, well, really it's not designed for, and you stress the cable too much, that could actually cause issues. And that's why it's also important they say, don't actually bend the cable until you're 35 millimeters away from the connector. What they're actually saying is once this is plugged into your graphics card, you should wait until you get to around there before you actually bend the cable, and that's to actually reduce stress, and that is a really important thing. And this applies whether you've got a squid adapter or native cable. So even with a squid adapter, don't bend things right at the very end where you've got the fabric thing where all the connections are happening. Leave 35 millimeters and then actually bend it after that. So that's going to be a lot safer than actually bending it right on the edge there. The next thing that cable mods actually talk about is making sure that the cable is plugged in all the way. And we all kind of know this, and certainly ATX 3.1 did actually improve this a lot by redesigning the female connector in the graphics card and any native PSUs. But in general, you need to make sure that these are plugged in all the way and that the latch is actually, it's not loose in any way. You need to make sure the latch is actually caught into it and you can't actually pull the cable back out. Then it can be really hard to know, especially if you've got an install, like a small form factor build where space is tight. You might not actually be able to see the cable too much, but just get as much light in there as you possibly can to try and see that there's no gap whatsoever between the actual, PSU cable and the actual graphics card. You need to make sure it's plugged in all the way. Equally with your PSU, if you've got one with a native, 12-volt power slot or 12-volt 2x6, then make sure that it's plugged in all the way there because you don't want any loose connections at all. And next we get a bit more scientific, and this is the actual ATX 3.0 specification from Intel. It's the original design document for the 12-volt power connector. And I know there's an ATX 3.1 for 12-volt 2x6, but actually when it comes to measuring our cables, the cable themselves haven't changed between ATX 3.0 and 3.1. And the first thing to talk about is on the bottom of page 52, we look at this section about 12-volt power for, 600-watt cables, which is probably what we're going to have if we've got like a higher end GPU. And the first thing it's talking about is that each actual current wire, or the live wire or hot wire, as you might want to call it, should not go above 9.2 amps. And we'll talk more about that in a minute, and we'll actually look at a DC clamp meter and how we can measure that and why it's so important. But essentially with a 12-volt power cable, what you're going to have is 12 pins. And as a result, you're going to have 12 wires too. And basically 6 of them are ground wires, and then 6 of them are your hot ones or your current ones. And effectively what it's saying is each individual current wire should supply no more than 9.2 amps. And we'll come back to that point in the next section. The next thing then is it's giving dimensions about the actual connector and everything else. And when people are wondering why is this so small, Well, it's because Intel and Nvidia, when they designed 12-volt power, they designed it to be really small. Now, what this doesn't talk about is the actual per pin variance. If you actually look at it, there's nothing talking about that, but we will talk about the per pin variance a little bit later because I've spoken to Corsair previously and they've given this diagram. So we will talk about the pins because I know Jay's 2 cents done a video on this before. He was concerned about Corsair's cables, so we will talk about that. But in general, there's nothing about the per pin variance there. But if you did have a cable from like AliExpress and it looks a bit weird and different, you could always compare it to this specification with an actual digital caliper and then actually try and work out whether that particular cable is in line with the spec or not. But next I wanted to go on to some actual practical theory. Okay, so I've spoken earlier about the fact that in a 12-volt power cable, you're going to have 6 ground wires and then 6 hot ones or current carrying ones, whatever you want to call them. And at this point we should run Fermark and then I'll talk more about what I'm actually planning on doing. So yeah, let's run Fermark, and this is a free download. If you don't already have it, just download it. It's completely free, and then you click on Run Test.
A few moments later.
I've run Fermark and basically it's drawing 300 watts. If you've got, RTX 5090, that's going to be 600 watts. If you've got a 4090, it's going to be 450 watts, etc, etc. But the point is, it's drawing 300 watts. And if you indulge me in a little bit of math, and this is really important for actually, being able to test this with the clamp meter, so just bear with me for 1 minute. But basically, we know that watts equals volts times amps. That's the standard formula. And as a result of that, what we can also say is that watts minus the volts equals the amps. And we also know that this is a 12-volt power cable. So we can basically say that if you get the maximum wattage of your GPU, or what it's using right now, so 300 watts, and you divide that by 12, that's going to be your ideal amperage. So, if you've got 5090, what you're actually going to end up with is 600 watts by that means basically in general, you've got 50 amps in total. And we know as well that in a particular 12-volt power cable, we've got 6 hot wires or 6 current carrying wires. So effectively, if we divide this number by 6, that's the total number of amps that a single pin or a single wire should actually be drawing down. So in the case of a 5090, what you're actually going to say is you should be looking at around 8.33 amps per wire for a 5090. And that is why actually if you look at the specification, it actually says about 9.2 amps per pin/position. And I'm banging on about this quite a lot because if, for example, you bend your cable too much or you've got a faulty cable or anything like that, what you could actually find is that one of the pins in here pops out a little bit, and Barrow has shown this before. And what could actually happen is, let's say 2 actually of your pins have popped out, they're not going to carry 8.33 amps anymore. And that then leaves the slack to the other 4 cables. And that's why we have melting. And that's why it's really, really important we get a DC clamp meter so we can actually test our, 12-volt power cable while Fermark is running. And the first thing you need to do is work out which of your wires are actually the ground ones and which are your current ones, because we're mainly interested in the current ones here. And the best way to do that really is actually you're going to get your DC clamp meter, you're going to turn it on, go to the DC mode, make sure it's not on AC mode, and then actually just go through each and every pin and actually look at what sort of readings you're getting. And what I found in the past, for example, is your ground ones aren't going to have much amperage at all, whereas your actual current ones will. And what you'll do, you'll go through each and every cable, and then you'll be able to work out which of your 6 wires are your current carrying ones and which are your ground ones. What I then tend to do is put some sort of zip tie on them, or something like that, just so you can actually know, right, so I'm going to ignore the ground ones, and then you've just isolated the current ones. And I think that's really worth doing. Next though, we can actually look at the per pin amperage or the per wire amperage and actually make sure that's correct. So we're going to go through each one. This is drawing 4 amps. This particular one also 4. I shouldn't say 4 amps, that's not very scientific. Next we come to this one, also 4. So there is slight variance, like sometimes it's 4.1, sometimes it's closer to 4, but yeah, in general it's close enough. Like you're going to get a little bit of variance, but what you don't want is a significant amount of variance. Okay, so that's over 4.1, and then that's 4.2. So actually that's the most variance we've seen. But basically there's no specific published variance for, the amperage of each individual wire, but we do know that there's a 5% variance when it comes to the 12-volt power, standard, and as a result I'd probably apply that to the amperage too. So if you were expecting around 4.16 amps, I say around and then give a really specific figure, but if you're, expecting that for your 5070 Ti, then the readings I had were fine. Like some of them were closer to 4, which is within that 5% variance. Some of them were beyond that, and that's absolutely fine too, as long as it's not like way above, 4.3 or whatever that I actually seen. Equally with the 12-volt power cable, if you're aiming for 8.33, then going a bit below that or a bit above that would be fine. But remember that the spec says 9.2, and I think anything, certainly above 10 would be a cause for alarm. You shouldn't really have that on an individual wire. And if you did, you should then actually look to, unplug the connector, inspect it for signs of damage, both on the cable and your graphics card and the PSU if you've got a native slot, then plug it back in. Next though, we can actually look at a thermal camera while running Firmark and see if that shows anything off. Before I do that though, actually, I wouldn't just run out and buy a thermal camera just because, you have a 12-volt power connected graphics card. I think it would be overkill, but if you actually have got a thermal camera anyway, then you may as well learn how to use it. But in all other cases, a DC clamp meter is actually better and it's more accurate, in my opinion. And the idea behind a thermal camera is it's obviously going to show you inside your system. It's going to show you where all the heat is. And obviously what's really important about that is that you can look at your 12-volt power cables that we looked at earlier, and you can actually inspect them with a thermal camera. But the main idea here is, because we zip tied them, we know that these 6 wires are actually the current carrying ones. And what you could actually look at is whether any of the wires are specifically warm. But if we actually look at it, I think they're all fine. But the benefit of this test is, let's say, these 3 wires are completely damaged and they're not carrying any current whatsoever, then these 3 ones should be a lot warmer. Effectively these ones should be like blue, and then these ones should be super warm. And, we're not seeing that, and that's actually, in my opinion, quite a good sign. And equally, we know as well from the spec that actually you should have, 30 degrees above the specification for each actual wire. And we're not seeing that here either. We can actually see that in this room, which is 20 degrees Celsius, none of the wires are going above, 40 or something. So they're all well within the specification as well. One of the final things you could potentially do if you wanted to check your cable is correct, like you bought it from AliExpress and you're just not sure and you want to do every test under the sun, is I shown that on the ATX specification, there's certain measurements about exactly how the connector should look. But what you can actually do is measure up the variance inside the connector as a whole. And the reason that some people are talking about this is around a year ago, Jay's 2 cents put out a video where we noticed that Corsair's 12-volt power cables actually seem to have quite a lot of variance in the individual pins. And as a result, Jay's 2 cents was wondering, could that be contributing to melting and everything else? And basically, in the end, I actually went out to Corsair and I spoke to them. And the short answer is, it's probably not worth worrying about. In general, the per pin variance isn't really something to be worried about because these connectors are designed to have some variance. Whether you're connecting up the motherboard one or the CPU one or a 12-volt power cable, there's always going to be some movement in the pins. That is completely by design because when you actually plug in a cable in, you want to make sure that good contact is made. And if everything was completely fixed inside the connector, then you couldn't guarantee that good contact is going to be made. So that is why there's some variance. But yeah, if you did want to test it, what you'd have to do is actually get a digital caliper. You'd have to measure up the actual tolerance there, and then you'd have to find some way of actually measuring the depth of the metal inside the connector. And some digital calipers actually have a bit of plastic that comes out where you could put that in and then actually measure the variance between the topmost pin and the bottommost pin. Unfortunately, I can't do that because my son snapped this off. But I'll link to the other video I've done in the description because I go into this in a lot more detail. But to be honest, I don't think it's worth actually testing the per pin variance. It was good that Jay's 2 cents discussed it and raised the question, but actually there should be variance, and I think they're using a clamp meter as we looked at earlier. I think that's a lot more important. But anyway, that is one of the final ways you can test. If you've got any further questions though about anything I've covered, please leave me a comment, and if you enjoyed this video, please click the thumbs up button and please subscribe to see more videos like this. Thanks for watching.